I hope you can still see my whiteboard, eh? Hello?
Yes.
Good. So properties of limits. Some people call them laws of limits. Some call them theorems of limits. So properties, laws, or theorems of limits actually will be interpreted to mean the same thing in this context. So if L, M, C, and K are real numbers, and we have limit as x approaches C of f of x equals to L, and limit as x approaches C of g of x is equals to M, then we have the following. So we have the following laws or properties for limits. So the first one is limit as x approaches C of f of x plus g of x will be given by limit as x approaches C of f of x plus limit as x approaches C of g of x, which will be L plus M. So this is to say that if you know the limit of a function f of x as x approaches C, and you also know the limit of a function g of x as x approaches the same value C, then the limit of this sum of the two functions is the same as sum of the limits. So we call this the sum rule. Then number two, limit as x approaches C of f of x minus g of x will be limit as x approaches C of f of x minus limit as x approaches C of g of x, which will be L minus M. So what special name can we give this from the structure of the statement? This will be called
subtraction.
Subtraction of difference rule, correct. So this is called difference rule. And then number three, limit as x approaches C of k times f of x is the same as k limit as x approaches C of f of x, which is just KL. This will be called constant multiple rule. This constant multiple rule. Then number four, limit as x approaches c of f of x times g of x is the same as limit as x approaches c of f of x times limit as x approaches c of g of x, and this is the same as L times M. So what special name can we give this from the structure of the statement? Come again? What name can we give this rule?
Product rule multiplication.
Product rule, correct. So this is product rule. But when you want to define the limit of product of two functions, it's the same as product of the limits. Then number 5, limit as x approaches c of f of x over g of x will be the same as limit of f of x as x approaches c divided by limit of g of x as x approaches c, which is L over M, and we are putting a restriction that M can never be 0 for that to be defined. So what special name can we give this?
Division.
Division. So division, we call it quotient rule.
Quotient.
Yeah, so this is quotient rule. So this is called quotient rule. Then second last, limit as x approaches c of f of x raised power n is the same as limit of f of x as x approaches c power n, which is L power n. So this n can be any real number. So what name can we give this from the structure of the statement?
Power.
Power rule, correct. So this is power rule. Then lastly, number 7, limit as x approaches c of the nth root of f of x is the same as the nth root of limit of f of x as x approaches c, which is the same as the nth root of L, which is the same as L power 1 over n. So what special name can we give this? So you can just call it root rule. So that's what you can. So then now, I want us now to use this. Once we have now stated the properties or theorems or laws of limits, then now we give examples to illustrate how to apply them. Okay, maybe number 8, just to make things clearer. So limit as x approaches c of k is always k. So this means the limit of a constant is always the same So regardless of where x is approaching to, if the function does not depend on x, then the limit becomes the same value. So for example, if I ask you, evaluate limit as x approaches 2 of 10, then the answer just becomes 10. Because the function f of x does not depend on x. If limit as x approaches 5 of 7y plus 10, the answer becomes just 7y plus 10, because this function depends on y and x, the limit variable is x. So this remains the same way it is. So if I say limit as h approaches 3 of 2x plus 4, the answer remains to be 2x plus 4, because the limit variable is h, while this part, there is no h. So limit of a constant is the same constant, regardless of where the variable of limit is approaching to. So use properties of limits to evaluate the following. So we always start with appetizers. The first one, please note that let it be very clear. When you have been asked to verify a limit, you use epsilon delta. But when they ask you to solve or find or evaluate, then forget about the stories of deltas and epsilons. So here is just now the working out of the problems. Delta epsilon only comes in if they have given you the value of the limit itself. But when you are asked to solve or evaluate or find, L is not given, and so these properties and what will other methods that we'll discuss later on after this are the ones to be used. So epsilon and delta are not in picture in this section here. So the first one is limit as x approaches 2 of 3x plus 9. B, limit as x approaches 0 of 3x squared minus 2x plus 1. And then C, limit as x approaches C of x cubed plus 4x squared minus 3. D, limit as x approaches 4 of x squared plus 5 over x 2x plus 3. And then E, limit as x approaches C of x power 4 plus x power 2 minus 1 over x squared plus 5. F, limit as x approaches 2 of square root of 4x squared minus 3. So this should be enough to enable us to understand concept of properties of limits. So once you are ready, let me know so that we can solve the problems together. Can we solve the problems now?
Yes.
Yes.
Okay,
Yes.
fine. So the first one is to evaluate limit as x approaches 2 of 3x plus 9. So this one, these are sum of two functions, 3x plus 9. So you'll write this one as limit as x approaches 2 of 3x plus limit as x approaches 2 of 9. Then now we say that the constant multiple rule says that you can factor out this number 3. So this can be written as 3 limit x approaches 2 of x plus limit as x approaches 2 of 9. Now, when you say limit as x approaches 2 of x, simply mean that what is the value of the function as x gets closer and closer at 2, or is exactly at 2 itself. So simply directly substitute. So this will be 3 times 2 when you replace x for 2. Then what is limit as x approaches 2 of 9?
9.
9. Because these are constant. We say that limit of a constant is the same constant, regardless of where the variable of the limit is approaching to. So 3 times 2 is 6 plus 9 to get 15. So the value of the limit is 15. And then next one is a limit as x approaches 0 of 3x squared minus 2x plus 1.
15.
Yeah. So limit b as x approaches 0 of 3x squared minus 2x plus 1. So here you can write this one as limit as x approaches 0 of 3x squared minus limit as x approaches 0 of 2x plus limit as x approaches 0 of 1. So you can directly substitute, or if you want, you can apply the constant multiple rule. So this would be the same as 3 limit as x approaches 0 of x squared minus 2 limit as x approaches 0 of x, then plus limit as x approaches 0 of 1. So here you directly substitute where this x put 0. So we'll have 3, then 0 squared minus 2 where this x put 0. And what is limit as x approaches 0 of 1?
1.
1.
1.
So this will give us 0 minus 0 plus 1 to give us just 1. So the next problem, limit as x approaches c of x cubed plus 4x squared minus 3x. So supply limit to each part of this function. So we'll have limit as x approaches c of x cubed plus limit as x approaches c of 4x squared minus limit as x approaches c of 3. Then you directly substitute where there's x, you put c. So we'll have c power 3 plus 4c squared And then limit as x approaches c of 3.
3.
3.
Yes.
So this is the final answer to that given problem. Then D, we have x squared plus 5. So limit as x approaches 4, x squared plus 5, and then 2x plus 3. So what is the first law to be applied in this case?
Sum rule.
Sum rule, will it be the first one? By the nature of the function itself.
Quotient rule.
Quotient rule first, yeah. So this is the same as limit as x approaches 4 of x squared plus 5 over limit as x approaches 4
Quotient.
of 2x plus 3. So the first step is to use quotient rule because now the function is in the form of a fraction, or two polynomials have been divided. So this will be now in the numerator you use the sum rule the way you are saying. So we'll have limit as x approaches 4 of x squared plus limit as x approaches 4 of 5 over limit as x approaches 4 of 2x plus limit as x approaches 4 of 3. So that's now, this first one is quotient rule. Now this one is sum rule. So the numerator, the first limit will be this value, 4 squared plus
4 squared.
Plus 5.
5.
plus 5 because these are constant, and then these are done 2 times 4, then plus
Plus
3.
3.
plus 3, correct.
2
So we'll have 16 plus 5,
plus 4.
and then 8 plus 3. So when you simplify,
4.
you get
3.
3.
Z.
Sure. This 3.
It is not 3. 21 over
16
11.
plus 5 is
7.
21.
21 over
1.9. 1.
11.
11, yeah. So even if you live in 11, 21 over 11 is still okay.
21.
Yeah.
Then
And then E, we have limit as x approaches C of x power 4 plus x squared minus 1 divided by x squared plus 5. So which rule are we supposed to apply from the start?
Quotient.
Quotient rule, because it's a division of two functions. Yes, correct. So this will be given by limit as x approaches C of x power 4 plus x squared minus 1 divided by limit as x approaches C of x squared plus 5. So that is step 1. Quotient, because the function happens to be a division of two polynomials. So then now, after quotient rule in the numerator, we use both sum and difference rule. So we'll have limit as x approaches C of x power 4 plus limit as x approaches C of x squared minus limit as x approaches C of 1 divided by limit as x approaches c of x squared plus limit as x approaches c of 5. So can you tell me the numerator first limit will be?
C raised to power 4.
C power 4, correct? So just by directly substituting where there's x by c. So I'll have c power 4. Then second limit in the numerator,
C
C
power
power
C
2.
squared
Power 2.
c squared, then
1.
minus
one.
1 over
C squared plus 5.
c squared plus 5, correct? So this is the final answer. Then lastly, we have limit as x approaches 2 of square root of 4x squared minus 3. So what is the first rule to be applied in this case?
Root rule.
Root rule. So root rule says that now we'll have the square root and we bring in the limit. So we'll have limit as x approaches 2 of the function 4x squared minus 3. That's by root rule. Then inside the root sign, how do we evaluate the limit?
Limit.
Limit
Gets 2.
x approaches 2 of which rule do we apply from that after this step? Difference rule, correct. So we'll have 4x squared, then minus limit as x approaches 2 of 3, correct. So the first limit will be, you can as well go further and use the constant multiple rule here so that we have 4 limit as x approaches 2 of x squared minus limit as x approaches 2 of 3. So limit as x approaches 2 of x squared.
Four times 2 squared.
Yeah, so 4 times 2 squared. And then limit as x approaches 2 of 3.
3.
3.
3.
Because it's a constant. So 4 times 2 squared minus 3.
13.
13. So because we have 16 minus 3, which is just the square root of 13. Just leave it in sad form, it's okay. Then can you solve this?
Root 12.
Limit
Root
as x approaches 1, approaches minus 1 of x power 3 plus 4x squared minus 3 divided by x squared plus 5. Use limit properties to evaluate that limit. I can use 1 minute. What answer are you getting?
Negative 3 out of 6.
Minus a half?
Which is minus half, yeah.
Sure.
Z.
Any other answer
No.
apart from
0 over 6. Infinity.
is 0 over 6, which
Zero.
it chooses to?
Infinity. Something like
0.
You should
0.
actually find that when you work out, you get 0 over 6, which is just 0. Okay.
yes.
Remember, the infinity will be when now you have 6 over 0. But when you have 0 in the numerator, there's no problem. So the answer is 0. So confirm that the answer is 0 for that limit. Check that when you work out, you get 0. So methods
Yeah.
of computing So methods of finding or computing or calculating or evaluating limits. So the first method is called direct substitution. B, we have what we call factorization. C, rationalization. D, L'Hospital's rule. So these are the methods we use to compute or calculate limits. So then we will discuss, I want to give problems, and then these problems, we will be discussing any of these rules that I'm stating here. But just to make things clear, this one, this cannot be done at this level because you're still young. You need to understand the concept of differentiation to be able to apply L'Hospital's rule. So that will come after discussing derivatives of functions. So here what we only measure on or discuss is direct substitution, factorization, and rationalization as methods of computing limits. L'Hospital's rule is another method which will be reasonable after understanding how to compute derivatives. So evaluate the following limits. I still repeat, when you are being asked to evaluate or solve or find or calculate, don't even imagine of epsilon and delta in those problems. Epsilon and delta are only respected when you are proving limits, but not calculating limits. So the first one is limit as x approaches 2 of x squared plus 4 over 3x plus 5. B, limit as x approaches 2 of x squared minus 4 over x minus 2. And C, limit as x approaches 2 of square root of x minus root 2 divided by x minus 2. So these are good appetizers to start us off. So write those 3 problems. So before actually you are given an admission for this course, we are acutely aware that you must have been in Form 2 and Form 3. So in Form 3, you dealt with the SADs. So when we talk of rationalization, you know how to do that one when you have a SAD. And then factorization is what was done both in Form 1 and Form 2. So it's never a big problem to use those 2 methods. And direct substitution, really by the name itself, simply means that you replace the numerical value of the x value in the limit and then simplify the resulting expression. And to make things clearer from the start, because when you will be given questions on limits, we will not tell you that now this is the rule, this is the method you need to use to get the answer. The question will just be open, evaluate the limit. So what you normally do from the start, you start by directly substituting. And if after substituting, you don't get undetermined forms of this nature, like 0 over 0, or say infinity over infinity, or 0 power 0, if your answers are not of this form, the so-called indeterminate forms, then direct substitution works for that given limit. But if you directly substitute and you get something like 0 over 0, or say infinity over infinity, or something like 0 power 0, then you know that direct substitution is not the appropriate method for that limit. So you now sort other methods, say factorization, rationalization, or say L'Hopital's rule. So before you start struggling with those other 3 methods, the first step is to directly substitute. If you get indeterminate forms, 0 over 0, or these other structures of the expression, then you opt to a different method. So from the start, in the first problem, we have limit as x approaches 2 of x squared plus 4 divided by 3x plus 5. So we directly substitute. Where there's x, you put 2. So I'll have 2 squared plus 4 divided by 3 into 2 plus 5. So what is the simplification of the numerator in this case?
Eight.
8. Denominator?
11.
11. So 8 over 11 is actually a defined fraction. So there's no problem with that fraction. So therefore, the answer to this limit is 8 over 11. So this one has been solved by just direct substitution. Is the method that is giving the answer. Then B, we have limit as x approaches 2 of x squared minus 4 over x minus 2. Let's see if direct substitution works. So we'll have 2 squared minus 4 over 2 minus 2. So what is 2 squared minus 4?
0.
0. And what is 2 minus 2?
0.
0.
0. So when you get 0 over 0, then actually you are in a hole. So the direct substitution does not work because 0 over 0 is undefined. So because of that, then direct substitution is not the appropriate method to compute this limit. So sort for a different method. And is very clear that x squared minus 4 can be factored in terms of x minus 2. So x squared minus 4, when you factorize, you get what the factorization of x squared minus
2.
X plus 2, x minus 2, correct.
X plus 2, x minus 2.
Yeah. So then over x minus 2. And by doing so, the factorization of the numerator now produces a factor which is the same as what we have in the denominator. So this reduces to limit as x approaches 2 of x plus 2. And immediately you do factorization and you cancel out some factors in the expression. It is always true in general that the expression you get after simplification will always give you the limit by direct substitution. So then with this new expression, we simply substitute where there's x by 2. So we'll have 2 plus 2, and this gives us 4. So therefore, the limit for that given function is 4. Then C is limit as x approaches 2 of root x minus root 2 over x minus 2. So what is by direct substitution, this will be square root of 2 minus square root of 2 over 2 minus 2. So root 2 minus root 2?
0.
0. 2 minus 2?
0.
0. So this is still undefined. So direct substitution does not work for this limit. And when you see a square root sign, a root function in your limit is actually one of the key things that can trigger your mind to tell you that you're actually going to do some rationalization. If you remember your Form 3 work, if you see things which have some surd or root signs, then that can actually be a prompt to tell you that the best or the correct method to apply is rationalization. So here we rationalize the numerator. So we'll have limit as x approaches 2 of root x minus root 2 over x minus 2 is the same as limit as x approaches 2 of root x minus root 2 divided by x minus 2. So to rationalize the numerator means you multiply both the numerator and denominator by the conjugate of the numerator. So what is the conjugate of root x minus root 2?
Root x plus root 2.
Yeah, root x plus root 2. Is exactly the same things we are doing from 3. So root x plus root 2. So root x minus root 2 times root x plus root 2 signifies to?
X minus 2.
X minus 2. Because remember, this this numerator, when you multiply, it's just like if I give you a minus b times a plus b, we all know that this is a squared minus b squared from our Form 2 work. So this is the concept we are using here. So when you multiply this, a number by its conjugate is just the same as the difference of two squares. So x approaches 2 of now x, because the root of x squared is just x, root of 2 squared is just 2. And you don't have to open this denominator, just leave it the way it is. X minus 2, then root x plus root 2. And you will not be performing any sin by putting brackets here. So what can you see? Or what should you do now in the next step from there? Cancel out, correct. Because you can see here that this x minus 2 and x minus 2 are common. So we'll have limit as x approaches 2 of 1 over square root of x plus square root of 2. And now at this point, provided you have done the proper thing on rationalization and you have simplified the expression, direct substitution must always work. So when you substitute where there's x by 2, you'll have 1 over root 2 plus root 2. And what is root 2 plus root 2?
2.
Okay, root 2 times root 2 is what will give you 2.
Oh,
But root 2 plus root 2 is not 2.
2 root 2.
2 root 2, correct.
2.
2 root 2. But it's always good manners to write denominator to be a non-sad form. So I can multiply this by root 2, root 2. And so I'll have root 2 over over 4. Please revise your Form 3 work. Take your maths book and revise, just to make you to remember some of these things you are doing. So that's what you do. So when the hint is that to know that this particular limit probably is testing on rationalization method is to see a function which has a sad or which has a root sign, and to know that the limit probably is testing on factorization is to, once you have directly substituted and gotten 0 over 0, you try to factorize a numerator and denominator and see terms which can cancel out to reduce the expression. And if you are successful on factorization and you do some crossing to simplify the given function, then once you do that one, direct substitution will always work from that step. So the other question is limit as x approaches 3 of x squared minus 9 over x minus 3. And then the other one is limit as x approaches 0 of square root of x plus 4 minus 2 divided by x. I want to give you 2 minutes to try this and tell me what you are getting. Try to solve these 3 limits. Once you get the answer, you unmute and then tell us, and probably tell us the actual value and the method we have used.
First one is 6.
So the first one is
6.
6. Correct.
Yeah.
Which method have you used to get that 6?
Factorization.
Factorization. Correct.
Factorization.
Yeah, so if you use factorization, you get the first limit to be 6. That's true. Second one? Or maybe to save on time, we can actually, from the nature of the function, which method do you think should be applied to problem B? If this is A, B, and then this is C. From the nature of the rationalization, okay? Yeah. So what you do, you'll say solution for B is limit as x approaches 0 of root of x plus 4 minus 2 over x is the same as limit as x approaches 0 of root x plus 4 minus 2. So what is the conjugate of the numerator? Conjugate will be?
Root x plus 4 plus 2.
Yes, root x plus 4, then plus 2. So remember, conjugate simply means you change the sign between the two terms. If it is minus, we change it to plus and vice versa. And then this is root x plus 4, then plus 2. So the simplification of the numerator after doing that product, remember you're just applying a minus b times a plus b always reduces to a squared minus b squared.
X.
X, so this will be x plus 4, then minus. Because remember, in this case, what we are letting to be a is this square root of x plus 4. This is b, this is a, this is b. So the square of a means square of this root x plus 4. So square and root cancels out, so I have x plus 4. Then square of 2.
Minus 4.
4. And then you need not to open the bracket here. Leave it the way it is. X plus 4, then plus 2. So x plus 4 minus 4.
X.
X. So x over x into square root of x plus 4, then plus 2. So from there, what should happen?
Cancel the x.
X cancels out. Yeah, correct. So this will give us limit as x approaches 0 of 1 over square root of x plus 4, then plus 2. So because now we have correctly done the rationalization, we have done the simplification, then at this point, direct substitution must always work. So this will be now 1 over square root of 0 plus 4, then plus 2. So 0 plus 4 is 4, square root of 4.
2.
2, so 2 plus 2. So the final answer will be?
Quarter.
A quarter. Yeah. So for me to be sure that you have understood, okay, now, okay, before we solve the previous problem, I want you to try this and see what you are getting. Limit as x approaches 0, square root of x squared plus 100 minus 10 over x squared. Can you use the same reasoning and process to get or evaluate the limit of this given function? There the limit will be
1 over 110.
4.
1 over 110.
1 over 110. Let me check. I have a different answer. Is everyone having? Is there anyone with a different answer? 1 over
1 over 20.
1 over
yeah,
20.
The correct answer is 1 over 1 over 20. So this how that answer is obtained, because we can see a root sign, then it's actually a rationalization method problem. So we'll have limit as x approaches 0 of square root of x squared plus 100 minus 10 over x squared is the same as limit as x approaches 0 of square root of x squared plus 100 minus 10. Then the conjugate of this one will be square root of x squared plus 100 plus 10 divided by x squared into square root of x squared plus 100 plus 10. Then we are still using a minus b. A plus b is a squared minus b squared. So the square of root x squared plus 100 is the square of root of x squared plus 100.
X squared plus 100 plus 100.
X squared plus 100 minus square of 10 is 100. And then denominator, don't open bracket, leave it, don't open this, leave it the way it is. It will make your work easier. X squared plus 100 plus 10. Now x squared plus 100 minus 100 will be?
X squared.
Just x squared. So divided by x squared into x square root of x squared plus 100, then plus 10. So at this point now we see x squared and x squared cancels out. So this and this cancels out. This will be limit as x approaches 0 of 1 over square root of x squared plus 100, then plus 10. So because we have done the correct thing on the rationalization and simplification, this next step is just to directly substitute x for 0. So 0 squared plus 100, then plus 10. So 0 squared plus 100 is 100. Root of 100 is?
10.
10. So 10 plus 10. So this is why you are getting 1 over 20. Now the other question was limit as x approaches 1 of x squared plus x minus 2 divided by x squared minus x. If you directly substitute, what do you get in the numerator? If you are to directly substitute for x equals to 1?
0.
0. And then denominator?
0.
Yeah.
Still 0. So 0 over 0 is undefined. So which means direct substitution method does not work. So therefore, because there is no root sign here, then this tells us that probably the correct method is actually factorization. Because rationalization is only used when you can see a root function in the a root in the function itself. So we have x squared plus x minus 2. These are quadratic expression. And in Form 2, you were told how to factorize quadratic expressions. So product in these cases, product
Negative
2, sum
Negative 2.
1.
1. Positive
1. Numbers which we multiply, you get minus 2, and you add, you get 1.
2 negative 1.
2 and
One.
negative
Times
1.
negative
Correct.
1.
Yeah. So which means then this can be written as x squared plus 2 x minus 2. So which will be this and this. So common here is x. So x into x plus 2 minus common here is 1 into x plus 2. So this will give me x minus 1, x plus 2. So that's the factorization of the numerator, and x squared minus x is very easy to factorize. What is common? Common factor for x squared and x?
X.
X. So this is the same as x into x minus 1. So therefore, limit as x approaches 1 of x squared plus x minus 2 divided by x squared minus x is limit as x approaches 1. So the numerator we have seen can be written as x minus 1 times x plus 2. Denominator factorization is x into x minus 1. So the factorization of those two expressions in the numerator and denominator produces a common factor of x minus 1. So which means we'll have limit as x approaches 1 of x plus 2 divided by x. So because we have done proper factorization and we have simplified to get a reduced expression, then the final answer will always be obtainable by direct substitution. So this will be 1 plus 2 over 1, which will give us
3.
3. So the answer becomes 3. Correct. So I want you to quickly solve the find the number, find this limit as x approaches 5, x squared minus 25 over x minus 5. The other one is limit as x approaches 1 of x cubed minus 1 over x minus 1. This is A, this is B, and C. Limit as x approaches 4 of x squared minus x minus 12 over x minus 4. And D, limit as x approaches 1 of x power 4 plus 3x power 3 minus 13x squared minus 27x plus 36 plus 36 divided by x squared plus 3x minus 4. Okay, these problems I'm writing, I'm not going to solve them. I want you will solve them at your own free time, but all the answers are in the link I shared to you. If you get trouble, you can actually go there and find the answers. And then the other one is limit as x approaches 0 of 5x squared minus 4 over x plus 4 plus 1. Then we have limit as x approaches 2 of x cubed minus 5x squared plus 2x minus 4 divided by x squared minus 3x plus 3. G limit as x approaches 0 of square root of x plus 3 minus root 3 over x. Then we have limit as x approaches 2 of 1 over x minus 2 minus 4 over x squared minus 4. So write those problems. You'll try them at your own free time. So then now consider some special limits. So limit as x approaches 0 of sine x over x. So I want us to find the limit as x approaches 0 of the function sine x over x. So if you are to directly substitute, what will be the value of the limit? Or what do you get if you directly substitute x for 0? If you directly substitute x for 0,
0.
you get 0.
0.
The answer is 0. The whole limit is 0. Or 0 is only for sine x.
Math error.
So I mean, we mean sine of 0 over 0. What do you get? So
0.
sine 0 from your calculator is
Undefined.
0.
0. So 0 over 0 is undefined. So if you put in the calculator, it gives you a math error. So recall from where we are starting from, that when we say limit as x approaches 0, means that we are getting closer and closer to 0. So if this is my number line and this is the number 0, let's say I have here -1, I have here +1. So this is minus infinity, this is positive infinity. So say this is minus 0.5, say here we have 0.5. So x approaching 0 means you can either reach this number 0. So this way you have the 0 mark. So to arrive at 0, there are two ways. You can either approach this 0 from the left-hand side, or you can approach this 0 from the right-hand side. So I want us to do to create a small table. We have x, and then we have f of x, which is sine of x over x. And then another table, x, f of x, which is sine x over x. So I want us to, this will be from left. This will be from the right-hand side. So I want us to, we want to walk towards the number 0 on this number line. So this table on the left-hand side is actually let's say x is -1. So I want you to tell me the value of sine of -1 over -1. What is sine of -1 over -1?
0.017.
Any other answer? So
0.1745.
Yes, 1 answer. Someone is saying that it is 0.0
174.
17 and some other decimals. Any other different answer?
No.
That the only answer?
Yes.
Okay, it's a wrong answer, but good for learning. So note, you were taught how to use calculators in Form 3. And if you are doing any computation, this will actually be a rule of the thumb. If you are using your calculator to get numerical values and you say these trigonometric functions, if you have trigonometric functions and you want to get numerical values using your calculator in the expression that you are using, always ensure that the mode of your calculator is in radians. When you have trigonometric functions, inverse trigonometric functions, hyperbolic functions, always ensure that if you want to get the numerical value using your calculator, the mode is changed from the normal degrees to radians. If you use your calculator to compute numerical values for functions involving trigonometric, inverse trigonometric, and hyperbolic with their inverse functions, you get wrong answers. So the 0.017 you are giving me is because the mode of your calculator is in degrees, which is wrong. So because this expression involves trigonometric function, then for you to get the correct numerical values, change the mode to radians and tell me the answer.
0.8414.
Yeah, 0.84147
Five.
etc. So that you must always consider that whenever you want to get numerical values using your calculator, and the expression you want to use has a trigonometric or inverse trigonometric or hyperbolic or inverse hyperbolic function, the mode must always be in radians. If you work with the mode in degrees, the answers you get will all be radians. So correct. And then can you, with the same calculator, can you now get for me the value of sine x over x when x is 1?
The same value.
Same value. So 0.84147. So then remember now, this is how we are working. So from the left-hand side, this table here, I was at -1. Remember, we want to get closer to 0. So let's now say we move to -0.5. So let x to be -0.5. So what is the value of sine of -0.5 over -0.5?
0.95885.
0.95885, correct. And when you go do the same thing for positive x, 0.5?
Same value.
Same value, correct. 0.95885 and other decimals, correct. So remember now we are at here. So we are closer to 0 than where we were at -1. Then can you, let's say, at -0.1. So get the value of sine x over x when x is -0.1.
0.99833.
0.99833. When we have positive x,
Same value.
same value, correct. So 0.99833. So then now I want also to I want us to even be closer and closer to 0 by now moving from -0.001 to say -0.01. So 0. Just a minute, I'll delete this. So I want us now -0.01. So we are saying the answer is?
.999.
How many nines after decimal?
4.
4. And then 8, 3. And then when it is positive, is it the same value?
0.
Yes, that's it.
The same value, okay?
999.
Yeah, 833. Good. And then let's even get closer to the 0 by saying -0.0001. and then 0.0001. So when we have that as our x value, then
Yes.
the function f of x will be how many nines after decimal?
6, 9.
6 nines. So what is the trend? What's happening if you can actually if you can try to observe the trend on how this how the value of the function is behaving? Remember, all these ones are leading us to the x value being 0. All these are leading us to x being 0. So as x becomes 0, what is the value of this f of x? The way the trend is move from 9 minus 1, go to minus 5, minus 0.1. As we move closer and closer to the number x equals to 0, what is the value of f of x? Don't disappoint your high school math teacher.
We are approaching 1.
We are really approaching 1. Because as we reduce this number of decimals, as we make this x values to be smaller towards 0, then we'll be getting 0.999999999. So which when you round off to nearest whole number, we see that all the numbers are converging towards the number 1 for f of x, both from the left and then from the right. So this will be the trend in either direction, and therefore we say limit as x approaches 0 of sine of x divided by x will always be given by 1. So put that one in your toolbox. These are very powerful standard limit that you must be aware of. That limit as x approaches 0 of sine of x divided by x will always give you 1. Then another standard limit that you need also to know is that even if I now interchange this one, limit as x approaches 0 of x over sine of x, if you do the same activity that you have done, you will still find that the answer is going to still to be 1. Then the third tool to be added on your toolbox is limit as x approaches 0 of 1 minus cosine of x divided by x is given by 0. That's another standard limit that you need to know. Limit as x approaches 0 of 1 minus cos x over x is 0. Then number 4, limit as x approaches 0 of cosine of x minus 1 over x is still 0. So take note of that. And then number 5, limit as x approaches 0.
And in this video, we're going to look at how to use the random function on the Texas Instruments TI-30X2S
This is 1.
using the simple function key that looks like this, located here, the PRE or probability key that looks like this, located here, and the right bracket.
We will revisit these limits when we'll graduate to the topic of differentiation. So ensure that you don't forget the tools you are adding to your toolbox.
Menu. And now we scroll to the right 3 times or the left once.
So a small break. I'll come up to finish in 20 minutes time.
Rand on. If we select rand, our calculator will give us a value between 0 and 1. So if we press enter on that, we see we get rand on our screen. And if we